Hi, I'm Mr. Huber, and in this video we're going to talk about problem 4a. Sketch the following function, f of x minus 3 times sine of pi over 4 x plus 2 brackets closed. Now look, well, a function, a transformation, a sine transformation always looks like this. We can clearly see no vertical translation because plus 0. Then plus 2 here, that means it starts at minus 2. So it's shifted to the left. Okay, shifted to the left by 2 units. So it starts over here. Well, remember, you may think, well, it's plus 2, so it should be shifted to the right. No, it's shifted to the left. Look. X squared looks like this, and x plus 2 squared is shifted 1, 2 to the left. I hope you remember that, okay? So it works the same here. So it starts here. Normally, a sine function would go up from this starting point, but well, look here. The amplitude is minus 3, so it will go down. It will go down, that's for sure. We already know that, because it's negative here. It's like if you put x squared, again looks like this, minus 3x squared is a sad parabola and a vertical stretch. Well, this is not a parabola, but it works the same for this coefficient here. So the amplitude is minus 3. Now the period length is 2 pi divided by b. And we're very lucky here because 2 pi divided by pi quarters, look, that's 2 pi times 4 over pi. So pi goes, and we can see the period length is 8. So from here, minus 2, we go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the middle. Now, it has an amplitude of minus 3. So we're always in between minus 3 and 3. Here we go, between 3 and minus 3. Well, it will go down like this, come up here again, and then go up to the highest point, and then end up here. That's one period length. I'm only drawing one period length here. Look, nice and rounded curve. Won't be perfect. It doesn't have to be perfect. This is more than good enough. Okay, so this is one period length of our function. Okay, well, it would continue here, obviously, and do something like this. And it would continue over here and go on forever. Okay, now, what is the geometric meaning of f of 4? Well, f of 4, this is 1, 2, 3, 4. F of 4 is in fact this y value. So this point is 4 and f of 4. It's the y value of this point. Well, work it out algebraically. Well, that's easy. F of 4 is minus 3 sine pi quarters, 4 plus 2, and brackets closed. Well, we can do this mentally. Sine, because this is now 6 pi quarters, so it's minus 3 sine of 3 pi halves. Well, we know what pi halves is, that it's 90 degrees. So 3 pi halves is 270 degrees. So look at this. In a unit circle, this is your sine value, this is your cosine value. As you go to 270 degrees, look, 270 degrees, or 3 pi halves, that's your arc length here. 3 pi halves. Your sine will be negative -1, okay? So this will be -3 times -1, which then is 3 minus 3 times -1, that's 3. So that means 4, 3. This is in fact one of the many maxima. Okay, there are many maxima here because it goes down and up and down and up, and this is one of these highest points, 4, 3. And f of 4, in fact, means the y value at 4, which in this case happens to be 3. I hope this wasn't too difficult. See you on the next one.